Hello, today I'll talk about conducting deep research using supervisor-delegation architecture with LangGraph. We'll be using a hierarchical delegation pattern with three phases: scope, research, and write. And the flow will go as follows. First, the user generates a request. Then our system asks questions if needed to fully understand the scope of the research. Then we convert the user message into an structured research brief and pass it to the supervisor into the research phase. Then this research supervisor analyzes the brief and delegates the research tasks to the sub-agents. These sub-agents will later conduct focused research, and then these findings are going to be synthesized and shared back with the supervisor. Then all the findings combined will be going through the write phase, where we're going to be writing the final report. Now we jump into the code, where we're going to start by defining the state. We're going to have three states: the agent state that has all the conversation messages, the supervisor state that manages the research iteration and the parallel researches, and the research state which has each sub-agent own message history, tool calls, and findings. This is how the code looks like, and this is where all the states are. Previously, we had the state defined in the main code, but now we're going to be having modules to separate the code from the main document. Here, the data flows down when delegating work and up when returning results. We are not using a unique stage like we did on previous videos, because a single huge state will create a tangled mess where all the components could interfere with each other's data and make parallel execution difficult. And now we jump into the tools. Here we're going to have tablet search for web searches, and for reflection and next steps we'll use think tool, which is a synthetic tool, basically a prompt that tells the LLM how and when to reflect. The difference between this and a normal system prompt is that this, being a tool, forces the LLM to do it, to reflect, and it creates a trace in the execution log. We will additionally have some helpers. This is how we actually call the tools. And then it is important to mention that having these components in different files and importing them makes the code cleaner, easier to read, and contributes to the reusability and modularity of the code. However, there's a downside of reduced visibility, higher debugging complexity, and requiring deep understanding of the code structure. Now, here's the configuration management for the Open Deep Research system. It is where we define the MCPs, APIs to use, and many other config settings that allows us to control how our system will operate. So here we can see different settings, like the max concurrent research units, the number of APIs that we'll be using, the MCP config, and some other important settings to keep in mind. Now we jump into the prompt templates, where we pretty much tell the different agents how they must behave. All of these prompts are here. Then we move into the node functions. We define the nodes in this stage, and we already described the flow of operations at the beginning of the video. So here are all the nodes, and then we jump into the graph construction, where we pretty much put everything together. Why is that we're using this architecture? Pretty much because it dynamically adapts to any research question, executes faster through parallel researches, and maintains quality through reflective reasoning, making it more flexible and scalable than rigid section-based approaches that we have used before. And finally, we run the deep researcher. We run the system. So here we can see the system running. Let me just show you the final report. And this is how it actually looks. But before showing you the final report, so this is where each of the nodes get into place. So as you remember before, we clarify with the customer, we write the brief, we pass it to the research supervisor, it does its magic, and then it writes the final report, which is this one. It even gives us good sources so we can compare that everything is given is actually factual. And the other thing I wanted to show is I run a test with different settings here just to compare the performance among them. So you can see here there's three different experiments parallel with two researchers. Experiment 2 is a sequential deep, and the third one is ultra fast. You can see how they have different settings here, and the results are interesting. So let me scroll down to the results. So for the first experiment, we got a time response of 52 seconds. The second one was the one that took longer, 201 seconds, and the third one was 57 seconds. So what can we tell from here? Parallel researchers, which is the first experiment, using two researchers simultaneously can cover more ground but using more tokens. The second one is a sequential deep, which is a single user with multiple iteration, allows for follow-up questions and refinement. It is better for depth. And the ultra fast, which is the third experiment, it requires minimal configuration, completes quickly, but provides less comprehensive results. Good for simple question. So the trade-offs is speed versus comprehensiveness. Faster configs gives quicker but simpler results. Token usage versus quality. It generates more searches, which is equal to better quality but higher API cost, of course. And finally, parallel versus sequential. Parallel is faster but uses more tokens at once. So choose the one you like. I believe that this requires more testing from my side, but it was a very interesting experiment. Hope you liked it. Hope you have a great day. Thank you very much.